So here we're going to be simplifying trig expressions using the fundamental identities. So you still want to have these notes out that have the different identities because we are going to use them to simplify. So what does it mean for something to be fully simplified? It contains the least number of trig functions. In this case, usually it's going to be one. And then contains no complex fraction. So a complex fraction would be like a fraction over a fraction. So like 1/2 over 1/4. So that would not be fully simplified if it had one. So you want it to have no complex fractions and then only one trig function. So for this example here, it says cotangent of x times sine of x. There we have two trig functions. We want to simplify it down to one. So what we want to do is we want to replace either cotangent or sine in order to see if something cancels out. A trick here, I'm going to type this in. The trick to doing this, change everything to sine and cosine, if you can. So that usually is a trick that works in most cases. If you're already given a sine and cosine, definitely do that. But yeah, so that is the trick. So for example 3, we have cotangent of x times the sine of x. So let's take a look at our trig identities and look and see if there are any that cotangent is equal to something involving sine and cosine. So here it says cotangent is 1 over tan. So we can keep that one in mind, but it's not sine and cosine. Here, cotangent is cosine over sine. Okay, that could be a potential. And I don't really see cotangent is negative. That's probably not going to help us. So let's try this one. And this is kind of like a trial and error process. There are different ways to go about this, different ways to do it. So I'm just going to show you a couple of different ways. So cotangent of u equals cosine of u over sine of u. So in this case, we're using x. So instead of having this definition with u, we're going to put cosine of x over sine of x. So we're going to rewrite cotangent. Instead of writing it as cotangent, we are going to write it as cosine of x over sine of x. So anytime you have two things directly next to each other, that implies multiplication. So here I wrote cotangent as cosine of x over sine of x because these two things are equal. So cotangent is equal to this. So I rewrote it. And then multiplied by sine. So here we can put sine over 1. And when we multiply across top and bottom. But you'll notice I have a sine on top and a sine on bottom. So those actually cancel out. So our final answer is just cosine of x. So now if we go back to the rules for what it is, what makes something simplified, contains the least number of trig functions, usually 1. So here we have 1 trig function, so we are done simplifying. So now we are going to move on to our next example, example 4. So for this one, we have the secant of theta over the cosecant of theta. So let's start out by changing both of these to sine and cosine. So if we remember our reciprocal identities, cosecant is 1 over sine, and secant is 1 over cosine. And so here, once again, it says u, but we are going to use the variable it uses, which is theta. So secant divided by cosecant, that is the same thing as 1 over cosine divided by 1 over sine. All right, so here I rewrote the fraction. Secant is the same thing as this. Cosecant is the same thing as this. Notice that I don't just write cosine and sine. I put the variable there. The variable is important. It needs to go there because these are functions. So you can't just have it alone without a variable. So now, if you remember what a fraction bar means, it means division. So we are going to divide 1 over cosine divided by 1 over sine. So if you remember anything about dividing fractions, 1 over cosine divided by 1 over sine, change this to multiply, flip this one. So we get 1 over cosine times sine over 1. So when we multiply 1 over cosine times sine over 1, we get sine over cosine. So that is 2 trig functions. Let's see if that equals anything. That's 1. So if we go up to our identities, we have, so it's going to be one of these. Which one? Let's see, what is it? Sine over cosine. So sine over cosine is equal to tangent. So that would mean our final answer is tangent. So 1 trig function, and we are done. And don't forget to write the variable, which is theta. So our final answer is tan theta. Done. All right, our last example gets a little bit tricky. Not too tricky, we can do it, but a little tricky. It has the sine of x times cosine squared of x minus sine of x. So a trick here, everything is already written as sine and cosine, but something you might want to think about is the fact that cosine squared x it has this squared. So anytime you see something with a squared, I want you to automatically think about the Pythagorean identities. And the reason I say that is because if we scroll up here, all of these Pythagorean identities have a squared in them somewhere. So like sine squared, cosine squared, tan squared, secant squared, they're all squared. So these might be something we want to use. Now you can rearrange the Pythagorean identities to solve for what you have. So for example, what I mean by this, if I want to replace cosine squared x, because maybe I want all of these to be sine, which would be a good idea. I need something that's equal to cosine squared x. So right now it is in this equation, but it's not solved for. However, we could subtract sine squared u over to the other side, and then we have cosine squared u alone. So the reason I need to do that is so that we have cosine squared u equal to something. We want it to be equal to something we can plug in for it. Right now, we don't have it on one side of the equal sign. We have 1 on one side by itself. We want to get cosine by itself so that we can plug it into the equation where cosine is. So to do that, we subtract sine squared u, and another way we can write this would be as cosine squared u minus 1 minus sine squared u. And that's because I took this sine and subtracted it to the other side. So now I have something that cosine squared u equals. This whole thing is the same as cosine squared u. So I can plug this in for this value. So how we would do that is plugging it in here. So it would be sine x times 1 minus sine squared u. So let's plug that in, keep everything else the same. So now we get something like this. So now, why don't we distribute sine x? So the process of doing these, you want to just keep trying different things. So right now, this is like a factored form. Let's FOIL it out and just see if something cancels. We're just looking to see if something will cancel. So if we multiply sine x times 1, we get sine x. If we multiply sine x times sine squared x, that would be like multiplying x times an x squared. We get sine to the third x. And then we have this minus sine x on the end. So now we do have something that cancels. So we have a sine x and a negative sine x. So those cancel out. So negative sine to the third x is what we are left with. And that is our final answer.